We are going to discuss today the graphing kinematics equations because it is always easier to draw the kinematic equations or the equations you get in physics. They are usually continuous and differentiable. It might be possible that you are not able to understand few terms I am describing here, that is like continuous and differentiable terms. But I want to tell you one thing. It is not very much difficult to solve problems, to graph equations in physics. You need to know some basics, like one of the basics you need to know about derivatives, and the second thing you need to know about asymptotes, but I will come later to this asymptotes through an example that will be convenient to you to understand, because when we draw a asymptotic curve we need to take care of few things. So how can you do this? Is it not particularly theoretical? It comes in many ways. But before that, I would try to learn that how can you use the derivatives. You all know, अब सबको पता है कि if you got a y versus x graph like this, then tangent to the graph, tangent to the curve at any point of it. Try to draw a tangent at any point of it, and tangent is just a line joining two adjacent points on the curve. Suppose you want to draw a tangent at this point. Let's name it pxy. Then you can take a point just after point P, or you can take a point just before point P and try to join them, and you will get a unique line, because you always need 2 points to draw a line. So when you get that line is called tangent. वैसे इसको velocity भी बोलते हैं. This tangent line is called velocity in physics as well. What are the reason behind calling them velocity? I will explain it to you later, but this is the tangent, and if the tangent makes an angle theta with positive direction of x-axis, the slope of this line, that is tan theta, is also called, tan theta is simply called as dy by dx. That is the derivative of y with respect to x, or you can explain it the rate of change of y with respect to x. So these are the things here. And now if you can do the other things, if you start thinking about these derivatives, I would suggest to do it in this manner, that if you got xy plane and the curve again, इस कर्व को कई पार्ट में डिवाइड कर सकते हैं. You can divide it in many parts, like I divided it between a starting point of the curve to the top of the curve. This is called local maxima here. So this is the topmost point in the vicinity of this curve, vicinity of this point. This is the topmost point of the curve, that is why it is called local maxima. And then I will take this local maxima and local minima point. This point is this point has got the least height from the x-axis in the vicinity of this point. So this is called the local minima. And here is the next part of the curve. ये अलग part है. And if we provide coordinates, x coordinates to these points, and say these points are x1, x2 and x3. So if you see between x1 and x2, the curve is basically, the curve is continuously increasing. If you move from x1 to x2, अगर आप x1 से x2 की तरफ जा रहे हैं, the curve will keep rising. It gets higher and higher between x1 and x2. That means in this region between x1 and x2, the change in x that we usually call dx, if we make our changes quite small, infinitesimally small, dx will be greater than 0. It will be positive because every x that starts from x1 and goes to x2, the later x is greater than the previous one. So dx will be positive. And if we move over this curve, the height of the curve also increases continuously. So you can also write dy, the change in y is also positive because y is increasing always. So change in y will be positive. That means dy by dx is positive here. This is not the usual way to explain the concept, but I think in this way we can explain the concept. Now you can see one thing at point x1, at the local maxima. If you try to draw a tangent will be like this, and this line is parallel to the x-axis. We sometimes call it the horizontal tangent if this line is parallel to the x-axis. The slope of this line is going to be 0 because tan theta is going to be the slope, and tan 0 is always 0. So at this particular point, tan theta is equal to 0. That means the value of dy upon dx becomes 0 here. And in the same manner, if you consider the points between x2 and x3, the curve falls. X is continuously increasing between x2 and x3, as did in this interval between x1 and x2. So dx is again going to be positive, but the curve is falling downwards this time, and y is decreasing continuously. So you should show that dy is less than 0, and it means dy by dx here is less than 0 in this region. In the same manner, in this region, dx is again equal to 0, but dy is greater than 0. So in this region, dy by dx is greater than 0. That means when a curve rises, dy by dx is positive. When a curve falls, continuous curve falls, dy by dx is less than 0. And when rises dy by dx, that means its derivative is positive, and when the curve falls, its derivative is negative. And at the points of local maxima and local minima, the derivative is equal to 0. And you should start making mind maps that when a curve rises, its derivative is positive. When a curve falls, its derivative is negative. And at the points of local maxima and local minima, dy by dx becomes 0. And if you see around this local maxima, you will notice one thing. At the left of the local maxima, dy by dx is positive at a point here. Say, for example, dy by dx is positive, here it is 0, and then at some other points, just right of the local maxima, dy by dx is negative. So around maxima, you will notice something like around maxima, dy by dx, the slope of the tangent to a curve decreases. Of course, it is 0 at the top, but it is only 0 at the top, not at every point near about the local maxima. इस पॉइंट पर 0 है उसका वैल्यू, ना उसके पहले 0 है ना उसके बाद में 0 है, बट उसके पहले पॉजिटिव है, उसके बाद नेगेटिव है. दैट मीन्स it keeps decreasing. The value of dy by dx keeps decreasing around the local maxima. And what about the local minima, the point here? At the left of it, dy by dx is less than 0, and at the right side of it, dy by dx is greater than 0. And only at this point, dy by dx is equal to 0. So we can observe in the same manner that dy by dx increases negative to 0 to positive. That means dy by dx increases around local minima. And the rate of change of a variable is positive or negative according as the variable is increasing or decreasing. अगर किसी वेरिएबल का डेरिवेटिव पॉजिटिव है, दैट मीन्स द वेरिएबल इज इंक्रीजिंग, और अगर किसी वेरिएबल का डेरिवेटिव नेगेटिव है तो दैट मीन्स इट कीप्स डिक्रीजिंग. और अगर किसी पॉइंट पर 0 है तो एक पॉइंट से कोई फर्क नहीं पड़ता. वी आर ट्राइंग टू फाइंड आउट ए पैटर्न हियर, नॉट वी simply don't want to have a particular value. We are not interested about a particular point here. If you want to tell something about a pattern that is whether increasing or decreasing, then you have to think about whether the values are increasing or decreasing. And in order to increase or decrease, it may become 0 in between somewhere. But being 0 at a point doesn't make it constant. So dy by dx around the local maxima is not constant. Neither it is at local minima. They are not constant. They are decreasing here and increasing here. So if we take the derivative of dy by dx, that derivative, what is the derivative of dy by dx? Then derivative of dy by dx, you know, is simply written as d2y upon dx square. It's read like this, d2y upon dx square. Oh well, you can, I think people these days pronounce it rightly, d square y by dx square. I don't have a problem. I'm from old generation, and then people told it usually call it d2y upon dx square. So I'm calling it today d2y upon dx square. And if dy by dx, if our variable is dy by dx, and if dy by dx is decreasing, then the derivative of dy by dx, that is d2y upon dx square, it must be less than 0, that means negative. And if dy by dx is increasing somewhere in a vicinity, continuously increasing, dy by dx is either continuously increasing or continuously decreasing. It may become 0 at a point. That doesn't make, because derivative of a constant is 0. If something is increasing or something is decreasing, its derivative is never 0. Derivative of a constant is 0. And since around the maxima, the derivative, the dy by dx itself is decreasing, not a constant. So d2y by dx square will be negative at the maxima, at the point of local maxima, and in the similar manner d2y upon dx square is greater than 0 around the local minima. That means you are going to tell something like if you ask about this point, but these points are not important here. The two points are important, which are local maxima or local minima. So at local maxima, at this point, you will notice that dy by dx is equal to 0, but d2y by dx square is not equal to 0, because dy by dx is not a constant here, it is decreasing. So d2y by dx square at local maxima is negative, and at the local minima dy by dx is 0 and d2y upon dx square is positive, not 0, because dy by dx represents the rate of change. It doesn't have any relation about a particular point. You have to find the pattern, and the pattern is that around this point the dy by dx keeps on decreasing, and at this point, around this point of local minima, the dy by dx keeps on increasing. So d2y upon dx square is positive around at this point, and d2y upon dx square is negative at this point. And when is the d2y upon dx square is 0? That usually comes into mind, because we know we can easily identify the points where dy by dx is equal to 0, but we need to identify the point where d2y upon dx square is equal to 0. And you can say that the whole curve, the kind of curve, is made of two different kind of curves. The first of it, that is towards the left, the curve is concave downwards, and at some point the curve changes its concavity, it becomes concave up. And if you can find the point where the curve changes its concavity, and that is usually called the point of inflection. The point of inflection is a point where a curve changes its concavity, if it changes, and mathematically you can always find by putting d2y by dx square equal to 0. So this is the point where second derivative of a continuous curve d2y upon dx square becomes 0. This is the point. This is usually called the point of inflection, where the curve changes its concavity. And now I have some final information for you about this curve, about this particular curve. The curve representing all the basic concepts of differential calculus. This is y versus x curve. Here is the point, I just guessed that here is the point where the curve changes its concavity, that is the point of inflection. And at this point d2y upon dx square is equal to 0. And for all of from here to here, the second derivative is negative. d2y upon dx square is negative. Why? Because dy by dx is decreasing continuously in this region, and in this region, for all of the region, d2y by including the point of local minima and in this case point of local maxima, d2y upon dx square is always positive because it is 0 at a particular point, so it must be negative before and must be positive before. It can be positive this side, it can be negative this side, but in this case, since we know that d2y by dx square is 0 at this point and d2y by dx square is negative here, that means in this whole region d2y upon dx square is negative, and in this whole region d2y upon dx square is positive because it is positive at here, and you have to keep them in mind. And if you can keep them in mind, and if you want to draw the graphs, the ordinary curves, you can, if you have these ideas and you want to draw simple continuous curves like a polynomial, for example, if you want to draw something x square minus 2x plus 1 like this, you have to do nothing. First, I would suggest that get few points you can easily get. Put x equals 0, not y equals 0. Put x equals 0 and get the value of y. So you can see here that at x equals 0, y is equal to 1. So this point makes a point whose coordinate is simply 0, 1. And then you can find dy upon dx, and this dy by dx you are going to find is 2x minus 2. And if I can suggest you, you can just put dy by dx equals 0. That means 2x equals 2. 2x minus 1 equals 0. That gives you x equals 1. And try, if you can, try to find out the corresponding value of y by just putting x equals 1. So if I put x equals 1 here, it becomes 1 square, that is equal to 1, and minus 2. 1 minus 2 is minus 1. 1 minus 2 is minus 1. And again you got plus 1. So it becomes 0, y equals 0, if I am correct. So this gets you a point where the coordinate is x equals 1 and y equals 0. And if you got this, I don't think you need any more things to find out. But you can find d2y upon dx square as well. And if you are willing to find, just try to find out d2y upon dx square. And this will be nothing but 2 only. And 2 is positive. So it decides the concavity of the curve. It has a unique value equal to 2. And 2 is positive, we all know. So the concavity of a curve will be like this. So you can draw them. X square minus 2x plus 1 right now. And you know how to draw them. The first point we got simply by inspecting this equation, that you got a point 0, 1. That's x equals 0 and y equals 1. So graph will pass through a point that is 0, 1. And then you have a point where dy by dx is equal to 0. That means the curve has a horizontal tangent to the x-axis. That is 1, 0, and it is something like here, 1, 0. And the concavity of the curve is like this. So curve is going to make its U-turn here, because when there is a U-turn, there will be either a local minima or a local maxima. That means the curve will have a horizontal tangent. Fortunately, in this case, x-axis is its horizontal tangent, x-axis itself. And here is the graph. So it may come in your mind that y equals ax square plus bx plus c. Well, might have a shape like this. This is called a parabola, if you know. This is a parabolic curve, symmetric, highly symmetric. So the curve will be like this. But you can try other graphs too using these concepts. So this was one of the general concepts you can use to draw graphs. I'm not going to tell you all the secrets right now because you have to learn it by yourself by hit and trial methods. You try to draw the curves, you will fail, but still you will learn. Because when you fail, you learn. And this is kind of thing. Let me give you a kinematic situation. Suppose that an object is moving along the x-axis. Along the x-axis, here is the origin where the observer will be residing, and its acceleration depends on time like this. Here alpha, beta are positive constants. Alpha is positive and a constant, and beta is also positive and both are constants. So the acceleration depends on time. We usually write it, acceleration is a function of time. Then we can find one thing in a very simple manner, by separating variables. We can get the velocity as a function of time and position as a function of time. And to find the velocity as a function of time, you should replace a by dv upon dt. And you can write equations as dv upon dt equals alpha minus beta t. One more step. You can write, just to separate the variables, you can write dv equals alpha minus beta t dt, and you can integrate them. Take the initial value, t starts from 0 to t, any moment of time later on, and v naught, let's make v naught equals 0, and you will get v equals alpha t minus beta t square by 2 after integration. And this is one equation. Then another one, second equation. Then to find the x coordinate of the particle, you can express v as dx upon dt, and you can write here dx upon dt equals alpha t minus half beta t square, and that means dx equals alpha t dt minus beta upon 2 t square dt. And again you have to integrate. You can take initial value of x equal to 0 as well, and then its x coordinate after time t will become x simply, so you should put limit here like 0 to t, and you are going to get these equations like x equals alpha t square, t dt alpha t square by 2 minus beta t cube upon 6. I just multiplied. Its integration will become t cube by 3, and I multiplied it by 2, so it becomes like this. So we have three equations. Like we have first equations, acceleration equals alpha minus beta t. The second equation for velocity was like alpha t minus beta t square by 2, and the third equation is like x equals alpha t square by 2. That means alpha by 2 t square minus beta upon 6 t cube. And if you want to draw these equations, the first equation is easiest to draw because acceleration depends on the linear power of t time. That means it's an equation like y equals mx plus c. So it's equation of a straight line, and its slope is negative, and t equals 0. The value of a was alpha, and it will be like this. And you know, when alpha is equal to 0, t is equal to alpha upon beta. A is equals to 0, t you will get alpha by beta. So it will be like this. If you want to draw it further, you can draw like this, but it should be a straight line. Now, if you want to draw velocity as a function of t, this is a parabola, and hopefully you can draw it. And at t equals 0, velocity was equal to 0, the first thing. So the graph starts from the origin, and at t equals alpha by beta, the acceleration was 0. That means dv by dt was 0. Acceleration is dv by dt, and it was equal to 0 when t equals alpha by beta. Dv by dt was equal to 0. So at t equals alpha by beta, the b versus t graph will have a local maxima or a local minima as well. They can be anything. But if you again differentiate, try to find out d2b upon dt square, you will simply get equal to dv upon dt is alpha minus beta t, that is acceleration, and d2b upon dt square, you can see from here that you will get minus beta only. So d2b upon dt square is negative. d2b upon dt square is negative. That means it will have a local minima only. The curve is concave downwards. So the curve will be like this, and we know that this is a parabola. So here to here the distance is alpha by beta. Then that means at this moment the time is going to be 2 alpha by beta. No problem in finding that. And I have started the motion at t equals 0, so I have taken the graph from here, and you can go further down, and this is it. And to find x in terms of time, you have an equation like this, that is alpha t square by 2 minus beta by 6 t cube. And you know few things like dx by dt is equal to 0. Velocity is equal to 0. Velocity has a maximum value at alpha by beta. Can you see the both graphs? Velocity is maximum at alpha by beta, and velocity is 0 at 2 alpha by beta. And velocity, that means dx by dt is 0 at here. Dx by dt is 0 at here. That means at this point somewhere the graph will have a horizontal tangent. I don't know where, but I can still guess. And then I can do few things, because I know between 0 to alpha and beta velocity is positive. So that means x is increasing. Velocity is positive, that means dx by dt is positive. So x is increasing with respect to time. So x keeps on increasing. And I started from somewhere, x equals 0 I took. So it at t equals 0, x equals 0. And then it keeps on increasing. And between alpha and beta, between time 0 to alpha and beta, you can focus again at here, x equals alpha by 2t square minus beta upon 6t cube, and v is equal to this, and acceleration, that is d2x by dt square. You can always keep these things in mind, that v is equal to dx by dt and acceleration is equal to d2x upon dt square. So at t equals alpha by beta, you can see from here, at t equals alpha by beta, acceleration is equal to 0. That means d2x upon dt square is equal to 0. That means curve changes its concavity here. At alpha by beta, the curve changes its concavity. And what was the curve between 0 to alpha by beta? 0 to alpha by beta, dx by dt was positive. And here you can see, and now we can add up things, and the curve changes its concavity at alpha equals beta. Here concavity must change, and before that, if its concavity was like this, it should be like this, because acceleration is positive between 0 and alpha. D2x by dt square, in this portion, d2x by dt square is positive between 0 to alpha by beta. That means the curve should be like this, concave upward, so curve should be like this, and concavity of the curve must change at this point. That means now on, the concavity of the curve will change, and we know the curve will be like this with local maxima at this point, because acceleration is going to be 0 at this point, 0 to alpha by beta, and it keeps right like this. So x versus t graph can be drawn like this. But you will have initial difficulties of yours by keeping all these things in your mind. So you should try to draw more diagrams. I can help you in a manner I can do. But finally you have to keep all those things in your mind by yourself. Nobody is going to rescue you. So I'm also not going to give you any hope or any lecture on it, because there are few things in life and you have to do it by yourself. So thank you very much for watching.